Hello, everyone. My name is James Strong, and this is Cube Philly for November. Let's see, today is the 16th, and we're going to have Melissa McKay from JFrog talk to us. But before we get started, are there any folks who want to introduce themselves to the community, working on projects, looking to get hired, or are hiring that want to present to the community? I see a couple new names that I haven't seen. If you're not too shy or anxious, go ahead and go off mute and introduce yourselves.
Hi, my name is Asifa. So I'm with Slalom. Not sure if you've heard of Slalom before, but we're a modern technology consulting firm. So this is my first time on this meeting. We are hiring, so just looking to meet more people.
Awesome. Thanks for joining us.
Hi,
Anyone else?
Yep. Hi, I'm Andrew. I work for Temple University. We have a team in-house that runs Kubernetes as a service for our internal development teams. And I'm an infrastructure architect there, and we're always looking to see what's new in the field so we can bring it to our developers internally. And this is a topic I was really interested in learning more about.
Thank you for joining, Andrew. All right. Got no one else. As always, I'm going to run through a couple things that I'm seeing, some blog posts I think you all should check out. I think that will be interesting. And then we'll go on to the main event. So we've got December planned out. I need to start picking up. So I'm going to be looking for speakers for January, February, March timeframe. Hopefully I can pick up some at reInvent. We'll see how that goes. But we do have December planned out already. So if you're interested in speaking, as always, please reach out to me. Got a couple announcements. So as some of you may or may not know, I'm one of the maintainers for Kubernetes Ingress Nginx. We've recently had a vulnerability that was out there, and we've just put out a patch for it. So if you haven't read about it, the vulnerability is listed in this issue here in 7874, and we've released a new version. So if you're running newer versions, if you're running Kubernetes Ingress Nginx, please upgrade and test and let us know and read a little bit more about the vulnerability. I'll make sure to post all of these links to the meetup page as well. I was reading a little bit today about this blog post of comparing CDK versus the AWS controller for Kubernetes. So if most of you haven't realized that they're consolidating all of their drivers and everything, all of the controllers into one for Kubernetes, AWS is. So this blog post talks about some of the differences between CDK and the AWS controller around a couple different things: programming, validation, execution, interaction, operation, reconciliation, a lot of things that are required from running in a Kubernetes mindset. So I think that's a good one that folks should read through and understand when they're deploying things in AWS, what they should be using. One of my favorite topics, as always, is cloud security. Security should be one of the number one things. You should always have your security team involved in doing the cloud migrations, any type of new services, and just hardening your cloud migrations. So this one talks through a little bit about doing threat modeling. I actually haven't done any threat modeling. Has anyone else done threat modeling from a cloud or just a security perspective? I'm interested to hear. No? Okay. Hopefully, Melissa, you can get them to answer your questions. But just walking through some of the common things that they see, helping secure some of the tools that are available to help catch any of those gaps. So I would recommend reading through this one. And then continuing down that security path, this blog post actually has a lot of, I don't want to say excruciating detail, but it has a lot of detail around threat vectors from an AWS perspective, looking at external attackers, malicious containers, and compromised or malicious users and how to defend against them. So again, security around your Kubernetes deployments and running and operating, I would think that you should go and look at this blog post. And as I said, I'll post all of these to the meetup. And if we've got no other announcements or anything, I would like to welcome JFrog here. So Ari's helped me out at other meetups before. He runs and does a lot of the operations for a lot of the awesome developer advocates at JFrog. So I would like to thank Ari for introducing me to Melissa, and we had a run-in at KubeCon. We were both in a little bit of a hurry, but it was just, it's always, a small little world. I like, I think you noticed me, right, Melissa?
I did. Yeah. We just ran into each other at a Starbucks at KubeCon. It's pretty cool.
That was fun. So Melissa is something I'm still aspiring to be, an international speaker. So an international speaker and a developer advocate at JFrog. And I'm very interested in this topic as well, because for Ingress Nginx, we're looking at moving off of Alpine. So I'm very interested to hear what you have today to talk about with DistroList. So with that, I'll go ahead and stop my share, and I should probably give you permissions to run the show.
Awesome. Thank you. All right. Should be able to see my screen.
Yep.
All right. Awesome. So I'm going to be talking today a little bit about DistroList images and securing your Docker images. And before we go any further, Ari really wants to make sure that you all go to this site, this URL here, and go ahead and register for this raffle. The first 15 people that do it, which guess what? There's less than 15 people here. So if you all go do it, you will get a JFrog t-shirt and a book. T-shirts are really cool. I'm wearing one today. I know Ari's wearing one too. So JFrog is known for their t-shirts. And in fact, I just started at JFrog about a year and a half ago, and I was wearing a JFrog t-shirt when I got the opportunity to work for JFrog. So pretty cool. All right, just a little bit of background on me. I am a developer advocate now, but prior to that, for plus 20 years, I was a developer, all the way from an intern to a principal engineer. And luckily, I was in a situation when I was an intern that I worked for a services company. We basically worked on anything that came in the door. So that gave me quite a breadth of experience across a lot of different frameworks, tool sets, languages. I think one of my first projects that I worked on was a Ruby on Rails project way back when. And then did a little bit with .NET, did some stuff with C# and C++. And then for most of my career, I have been a Java server-side developer. I am a Java champion now, and recently became a Docker captain as well, as I'm learning more and diving more deeply into containers, container images, and all of that, and the infrastructure involved in all of that stuff. While I was working my full-time job, I did get interested in speaking. This particular picture was actually taken in Scotland. I went to an unconference in Scotland. If you don't know what those are, they are very informal, small gatherings of developers. I really prefer those because you get more one-on-one contact with each other. And it's not really you sitting in a room listening to a speaker. It's more of a conversation with everyone involved in the topic. So pretty cool experience. When I started as a developer advocate, it was right when everything got shut down. So I'm looking forward to updating this picture at some point when I can get back out of the country again. We'll see how that goes.
I'm looking forward to that too.
Yeah, definitely. It was nice to get out for KubeCon. That was, I think, my second in-person event. The first one was Open Source Summit, which it was very, very small. Not a lot of people came, but it's nice to see them getting back up and running and getting back out there. And you mentioned earlier you'd be at reInvent. I will be there too. So maybe we'll run into each other again, maybe at another Starbucks, who knows?
I'll send you an invite. We're doing a book signing, so.
Oh, awesome. Good deal. Yeah, I love it. I love that.
Awesome.
All right, so today we're going to talk a lot about containers, a lot about container images, some of the history, some of the background, a look about like what it looks like on your system for a developer. All of this is going to be from a developer's perspective, of course, given my experience. And then I'll talk about some container gotchas, and that will move right into DistroList images, what they are, where to get them, how to use them, that kind of stuff, things to consider. And now we're going to talk all about containers. And every talk that I do on containers and container images, I refuse to use any graphics having to do with shipping containers. So you get bananas today. The whole thing is bananas. I've been using bananas a lot. I'll come up with something new at some point, but this is actually a talk that I've given a few times and I've modified a little bit for our purposes today. But I find bananas to be a great metaphor for containers. So enjoy. Next, we're going to talk a little bit about the history of containers. And there were, this goes all the way back to the 60s and the 70s. There were limits on time and resources, which created a lot of bottlenecks and inefficiency. And just being able to share a system was not enough. There needed to be a method to share without getting in each other's way or having one person inadvertently causing an entire system to crash for everyone. And this drove a need for better strategies in sharing compute resources. And that actually started a path of innovation that we see massive benefits from today. Lots of new frameworks out there and strategies for deploying your applications. There are some key points in time that brought us to today. So I'm going to begin our container history lesson with Chroot. I do think it's important just to get a refresher on the background of containers so we know where they came from and why they're here. This helps us make better choices surrounding their use. Chroot was born in 1979 during the development of the 7th edition of Unix, and it was added to BSD, the Berkeley Software Distribution, in 1982. Being able to change the apparent root directory for a process and its children, which Chroot allowed you to do, results in a bit of isolation in order to provide an environment, for example, testing a different distribution. In fact, Chroot was initially introduced as a testing utility. Obviously, Chroot was not enough. It was a great idea, solved some specific problems, but more was needed. The jail command was introduced by FreeBSD in 2000. Jail is more sophisticated than Chroot in that its additional features help further isolate file systems, users, and networks, and had the ability to assign an IP address to each jail. In 2004, Solaris Zones brought us ahead even further by giving an application full user, process, and file system space and access to system hardware. Solaris Zones also introduced the idea or popularized the idea of being able to snapshot a file system, which becomes pretty important when you are creating Docker images or container images. I'll explain the difference between Docker and everything else in a moment. In 2006, Google jumped in with their process containers. Those were later renamed to C groups, probably a more familiar term, which centered around isolating and limiting the resource usage of a process. And moving right along in 2008, C groups were merged into the Linux kernel, which along with Linux namespaces led to IBM's development of Linux containers. So you can tell containers are not a new thing. They've been around a long time. 2013 was a really big year though, and that's when people started discovering Docker. Docker came on the scene and brought their ability to package containers and move them from one environment to another. That same year, Google open sourced their Let Me Container That For You project, which provided applications the ability to create and manage their own subcontainers. And from here, we saw the use of containers and Docker specifically explode. In 2014, Docker they swapped out their use of the LXC toolset for launching containers with libcontainer in order to utilize a native Golang solution. So at this point, Google and their Let Me Container That For You project, those kind of joined forces in order to bring in all of those concepts into libcontainer and move forward with that library. I am almost done here with the history lesson. I know there's a lot of stuff on this slide, but I'm going to skip over some of these details around some of the different projects and organizations and specs that came out because
I think it's important, definitely, because of what's going on right now. So
definitely,
I think it's great.
Definitely important. Really important to understand the pieces and parts and how everything came together so you can understand what's actually being pulled apart now, especially in the world of Docker. In June of 2015, the Open Container Project or Initiative, also called the OCI, was introduced, that was established, and that is an organization under the Linux Foundation. It includes members from many major stakeholders, including Docker, with that goal of creating open standards for container runtimes and image specification. There are some really big names involved here. In fact, there are 20 plus companies that came together to form the OCI. Clearly, a lot of people were starting to use containers and container images, and we needed a way to have a common language, a common spec that everyone could agree on and use moving forward. While all of this is happening in the container world, there are a couple of other dates that are going to be important to Java developers specifically. That's me. So I'm going to force you to listen to Java stuff just for a moment, just because I'm selfish. But in July of 2011, Java 7 was released. Work was started on Java 8, which was released, that was in March of 2014. When you start containerizing Java applications, this little bit of history is important to know because of the interleaving of the timeframes here, the development of Docker and the development of Java. It's still important today because even though we're talking about Java 17 coming out now, a lot of companies, especially enterprise projects and applications out there, are still running Java 8 for various reasons. And so it's something that we still have to suffer with today.
Wasn't it? And it wasn't until I think it's 12, right? Java 12, where Java didn't understand C group memory management.
This is true. This is true.
Am I jumping the gun on you?
Oh yeah, no, it's fine. I'll touch on that a little bit later, but you're going right down the path that we'll talk about a little bit later. And it's Java 10 is 10. The most container aware. I would recommend getting to 11 if you can. If you're on 10, no reason not to be on 11, really. The biggest jump is from to 10, really, when they get the module system going. So, but 10 is a good one to start with if you're just looking at containerization. 11, the LTS version, is recommended. Now that we have some of that history behind us, let's take a look at a real life container itself on your box, what it actually looks like on your system. When I say your system, I mean my system. It's a Mac, so struggle along with me if you're not using a Mac, but you'll get the idea of how things are structured. So my first experience with containers was as a developer on a project. I was onboarding onto a project. This was several years ago, but I had never worked with Docker before or anything. Our project was on a deadline. It was a third-party project that had been brought internally that we were expected to maintain and add features to, that kind of stuff. So we needed to get things quickly up and running. We needed to set up our whole processes, our whole DevOps processes, make sure we had all of the source, everything. So the best course of action for me is just to get something up and running on my system immediately. And I learned best by doing. And the Docker documentation is actually really good right now. Back then, maybe I struggled through a little, but today they've really focused a lot on that and are really trying to make it easy for people to use. Also, they introduced Docker Desktop since my first experience. It's also very convenient to download to a Mac or a Windows machine and be able to use that. Docker Desktop, they are going through a change in their subscription licensing agreement with that. I know that the newer versions of Docker Desktop now you have to pay if you are with a company that has over so many employees and makes a certain amount of money every year. But for teaching purposes, like what I do every day with these, you don't have to pay. Or if you use an older version of Docker Desktop, note that you aren't subject to the new requirements around that. So if you find yourself in a similar position and you're just starting out, I recommend going through their Getting Started docs. I have a link here to that. And going through that guide will help you get comfortable if you aren't aware with some of the Docker commands that you'll need. And first to note is that a Docker image is really just a tarball of a complete file system. And when that image is unpacked, it's just thrown into its own directory, which becomes its root file system. The second is that processes that are involved in running the containers are just regular Linux processes. And on top of that, there are just a few Linux features that are used together in a way to achieve that isolation that we hope for in containers. Namespaces are an important ingredient simply because this is what's used to provide virtual separation between containers. This is how processes inside one container don't interfere with the host or processes inside another container running on the same host. And here you can see I have some namespaces that were set up for a Postgres container that I had running on my box at the time. The cgroups functionality is essential to constraining how much a container can use things like CPU, memory, network bandwidth, etc. And I can set these constraints by including options on the Docker run command when launching an image. Here, you can see that I've constrained the memory usage limit on one of my containers. This particular one was not a Java container, by the way, Java 8. I want to quickly gloss over some more file system details where containers and images are actually stored on your file system. As a developer, I ran into all kinds of issues when I was first learning. I had to figure out how to clean up containers, how to stop memory from just disappearing from my box, things like that. So I really dug in to figure out where everything was actually living, where everything was stored in my local development environment. First off, after you've installed Docker, running the command docker info will spit out a bunch of information about your installation, including the Docker root directory. This is where most everything you're going to care about regarding your Docker images and containers will be stored. And note that if you're on a Mac, your containers are actually running in a tiny VM, so you're going to need to use Screen or some other utility like that to get in there to actually get to that Docker root directory to look around. If you're not familiar with how to use the Screen command, definitely Google that, learn how to use it because it will mess up your text display pretty well if you don't enter and exit screen the right way. I had lovely experiences with that when I was first starting. One other thing to note is, especially on the host, that directory, varlib docker, can get pretty huge depending on how your application is behaving. So make sure that you have a disk attached there that is big enough to handle it, as well as make sure that your applications aren't logging to that all the time. Like if they've got internal logging going on and you don't have anything set up to ship those logs out, or like log rotation going on, that memory is just going to disappear out from under you and you'll start having issues with that directory getting overloaded. This slide shows how you can get information about the images that you have stored on your system. I listed here my available images using the Docker images command. I actually have several installed. I just have the first couple shown here. And using the Docker inspect command, I can inspect any image I like using its image ID. This will spit out a ton of interesting information, but what I want to highlight here is the graph driver section, which contains the paths to the directories where all of the layers that belong to this image live. Docker images are composed of layers which represent instructions in the Docker file that was used to build the image originally. These layers actually translate into directories. And these layers can be shared across images in order to save space. So pretty clever. The lower dir, merge dir, and upper dir sections are interesting to look at. The lower dir directory contains all of the directories or layers that were used to build the original image. These are read-only. The upper dir directory contains all of the content that has been modified while the container is running. If modifications are needed for a read-only layer in lower dir, then that layer is copied into upper dir where it can be written to. And this is called a copy on write operation. It's important to remember that the data in that upper dir is ephemeral data. It only lives as long as the container lives. So if you have data that you intend to keep, for example, if you have an application that relies on a database, You should utilize the volume features of Docker and mount a location that will stick around after that container dies. And that's how most of those types of applications are run. Lastly, the merged dir is it's kind of like a virtual directory. It combines everything from lower dir and upper dir. And the way that the Union file system works is that any edited layers that were copied into upper dir will overlay layers in the lower dir. So if you were to actually exec into the container and have a look around, this is what you see. This is what's visible to you. This slide shows that I actually have a few containers that are currently running on my system. Two of them is my local JFrog container registry installation, which includes a container for Artifactory and then a container for a Postgres database. The other is just a simple test container I was playing around with. And just note the container IDs of the running containers match up with the container subdirectory names. And something to remember here is if you stop a container, that corresponding directory does not automatically go away until that container is actually removed with the Docker remove command. So if you have stopped containers lying around on a host that never get cleaned up, you might see your available space start to dwindle. There is a Docker system prune command you can run every now and then to help clean things up, or you can launch a container with a flag to indicate that it should be removed when it's finished running. And a lot of orchestration frameworks also provide you this capability as well.
I definitely have ran into some volume mount issues because I've got too many containers just running.
Yep. I ran into it when I first started running. I just kept launching new containers. I didn't realize I needed to just start existing ones. And I definitely ran into that problem on my local development machine, just starting out. And deployment too. We had a deployment process where the old containers weren't ever cleaned up. They were just stopped and then new ones were deployed. Those were started and things went along fine for a while until memory just went away. So yeah, it's good to know, what's kind of going on under the cover so you know how to clean things up.
That's why observability and monitoring is important.
Definitely. So all of the tool sets that we have now around building and running images and containers have made things so easy that it's also very easy to shoot yourself in the foot in a few places. It can be deceptively simple. So I'm going to go over some of the common gotchas that I see time and time again. Some of them seem pretty basic, but I swear we forget and repeat. So I'm just going to bring them up again, including some of those JVM gotchas that we were about to discuss at the beginning. The first is running a containerized application as the root user. I've heard this over and over and over again. And I'll be honest here, when I was initially getting stuff up and running, I was so excited about how well it was working that it was a while before I took this one seriously and even noticed that there was a problem. Now that you know that processes running inside a container are just like any other process on the system, albeit a few constraints, it's scary now to run as root inside a container. Doing that opens up that possibility of a process escaping the intended confines of that container and gaining access to host resources. You want to reduce that attack surface of your container by following the principle of least privilege. And although containers are designed not to affect other running containers, if someone were to gain access to your container and they immediately have root privileges, they can wreak havoc on the host. Now, this can happen by accident too, especially if you have a situation where, and this shouldn't happen, but it does. I've seen it, where people are execing into containers just to look around and do some troubleshooting. They can do some damage without intending to if they're not, if they immediately have root privileges getting in there. How do we mitigate this problem? One thing to do is to create a user and use the user command inside of the Docker file when the container is built in order to run processes as that user. You may need to provide that user with the appropriate permissions as well. There is a way to specify a user when running the Docker run command when you're launching the container, but that leaves open the possibility of forgetting to do that. It is nice if your production image just by default does not run as root. Also, pay attention to official images that you pull from Docker Hub, whether or not they run as root or if they leave that up to you to fix in your own version using their images as a base image. No constraints. Even though Docker provides you with the ability to set resource limits on your containers, it doesn't automatically do that for you. In fact, the default settings are free for all. Make sure that you understand the resource needs of your application. Using containers are convenient, but it doesn't give you the license to be lazy and not understand the resource usage of your application. This is something that developers often like to skip over because, we don't care about that. We just wanted to write the code, ship it over, and let operations deal with resource consumption. But disagree that that is the best way to work. Developers need to take this on a little bit themselves and really understand how their application is using resources. And DevOps teams are really good at helping developers get on the same page there with operations. So make sure you understand those needs. Obviously, if you have too little, your container will die from starvation, and too much, the container can smother others on the system. The resource usage of your containers is something you're going to want to monitor. Like James said, monitoring is very important for your containers. It's a good way to determine if something is going wrong or if load on your system just has changed for some reason. Your application has become more popular. That's a good problem to have. You could use monitoring information to determine if that application needs to be split up further, if you need to make more plans in development to scale it differently. The best example is pulling something apart into microservices or pulling apart a front end versus a back end. Just depends on what your monitoring data gives you. Never updating. This is a huge security issue, and it's really easy to get complacent and not pay attention to what is actually getting pulled in when you build images. Images, especially when you're looking at a Docker file, you generally start with a base image. Well, that base image could come from another base image, which could come from another base image, just depending on how your application is built in your team. So not only do you need to be aware of the outdated versions that you specify that you're in charge of in your own Docker file and your own application, you need to pay attention in what's in that base image that it's coming from. Not updating those packages and libraries inside your container can lead to some pretty embarrassing results, especially when there are tools, so many tools available now to alert you when security issues have been discovered with specific artifacts. Even ensuring that you're running containers with a non-privileged user, even that has risk if there are known vulnerabilities that exist within your container or even on the kernel of the host. So from time to time, exploits are found that enable attackers to potentially escape a container. Once you have everything set up and you think you're safe, you must have a process where you continually observe stuff that's going on. Things come out all the time, and you need to be very reactive when things come up, when new vulnerabilities come out. So make sure you have a plan. I've been on teams where this has not been a priority, and that's primarily, at least in my experience, it was primarily because of the fear of breaking something that's already working. That's a symptom of different problems. A whole nother talk can be devoted to that. But trust me, it's much worse to leak private data or potentially be the start of a domino effect that can bring an entire system down, or even have just something embarrassing like all of your containers are falling over because people are mining Bitcoin. So pay attention to your stuff. All right, these are the JVM specific gotchas that James was alluding to a little bit earlier. This is very specific to containerizing job applications, very much related to being aware of what your application requires to run successfully regarding memory. That JVM is very clever at automatically determining settings for your swap and your heap and your garbage collection behavior based on things like memory and the number of cores available on the host. So this is all fine and good until you start running containers. Remember earlier during our history lesson, I mentioned the dates for Java 7 and 8. Considering that timeline of Docker and Java releases, 7 and early versions of 8, and certainly earlier versions, are not fully container aware. And this means that your Java application won't necessarily obey any memory and CPU constraints that you put on your container, and you may end up with some surprise out of memory killer activity. The reason for that is that the mechanisms the JVM used in these older versions to retrieve the resources that are available come from the actual host machine and not the C group limits like you would expect. There were some improvements around container awareness that were introduced in Java 8 update 131, and there were further improvements in later versions, but generally it involved setting a couple experimental flags in order to get it to work properly. To really get all of the benefits of container awareness, you really should get to Java 11, that latest available LTS release that is container aware. All right, image bloat. This can happen fast, especially if you've got multiple teams pulling in multiple different base images, all building off on top of each other. Also not paying attention to actually how a Docker build works. What happens when you're building a Docker image is you need to provide a context. What that context is everything that is available to the Docker daemon to use when it's building your Docker image. So for example, if you have a Docker file and you need to copy some source code over, or you need to copy a jar file over, or any other file, the Docker daemon needs to have the appropriate context in order to access that file. Well, something I see a lot, and which I certainly did without even thinking of it, is just send everything over there. The whole thing, my working directory, just send it over. And what you don't realize is that you're making available in that context some things you may not intend. You may have local configuration, you may have secrets, you may have testing stuff that you don't really want to end up in a production image. Even your .git directory is sent over there. So pay attention to what is actually getting sent in the context. And one way to control that, you can still say send everything, but take advantage of the Docker ignore file. It works just like your git ignore file. You can pick and choose, add directories and specific files to that Docker ignore file, so that even if you say send everything over to the Docker daemon, it will not have those files available to be accidentally included in your production image. So pay attention to that Docker ignore file. One other thing about image bloat is I do see a lot of building happening. People like to use their Docker files as a complete description of how to build the project, which is fine. It's just that when you get to the end of when the image is actually created, you now have stuff like Maven and Gradle included in your production image. You've got NPM, you've got all of these extra things that you don't need for your application to run in production. All it is doing is adding space to your image. That makes, the bigger they are, the harder it is to manage, to move them around, to make your containers launch quickly. Keeping that size down is really important. And one way to mitigate that problem is to start using the Docker multi-stage builds. What you can still include all of your build information, but then you have a second stage of the build that only moves into the image what you absolutely need for that project or that application to run. So let's move on to Distroless. You can see all of that was leading us to Distroless. What exactly is a Distroless container? It is the realization that there's a lot of stuff in these base images that you may not want, that are just increasing the size of your images. Docker has a set of official images, and a lot of us take for granted that these official images can just be pulled in and used as our base images. But you really should be paying attention to what is in those base images. And after this talk, I want to show you how to find that out. It was something I had to dig around a little bit to figure out. But it's good to at least know what is in the base image, what is being brought in that you may not be aware of because your application is just living on top of it. Those large parent or base images include a ton of stuff you don't need. For example, stuff I've already talked about, like there's a Java Maven image, for example, that includes the Maven in there, which obviously you don't need in a production image. Again, this is all about decreasing your attack surface area, eliminating things from your image that just make your environment more accessible to someone wanting to break in and do crazy things. And of course, shipping those large images around and storing them can become pretty clumsy, slow, and expensive, since we're all paying for every bit of storage we have now, especially in the cloud.
And even the network traffic of pulling it down from your registers.
Exactly. One thing about Distroless images is they certainly don't include package managers, and they also don't include a shell. Now that's interesting. I have come across folks that this scares them about Distroless images, because this means that they can no longer exec into this container in production to look around and poke around and do any kind of troubleshooting. There are versions of Distroless images that are debug versions that you can use for a development environment if that's what you really want to do. But by the time you get an image into production, that is the wrong way to be doing any type of troubleshooting or anything like that. Make sure that you at the very least, if you want to know what configuration a container is running under, spit that out in a README file at the beginning when the container launches, when it runs, and have that available for you to look elsewhere other than execing into the container to see exactly what it's connected to or what it's talking to. So there are ways around that, and I think by not having a shell, it kind of forces you into another set of best practices when it comes to observability of your application. This file here is an example of a multi-stage build. The line in line 1, that's a full-on OpenJDK 11 image. Well, it's a slim image, so a little smaller than the full thing. And this little Java application is compiled in there and built. And then line 7, we bring in the Distroless image, which has the bare minimum of what we need. Line 8, we just copy what we need from the build environment, which was set up in that first stage. And then we have our command, we're ready to go. Google has a few Distroless images. They're all based on Debian, but they've all been, they're kind of optimized around a particular environment, whether it be, Java or Python. There's a link here to other Distroless images that you can look at. And they are quite a bit smaller. They are, and we'll take a look at just one set in a moment. And we'll just, I don't like to believe everything I'm told. I want to actually look at it and see if it's true. So we will do that together in a moment. All right, one thing that James mentioned was network activity. When your developers are constantly pulling down these base images, there is a caching mechanism. Once you pull down an image from Docker Hub, it lives on your machine until you delete it. But think about this as far as like your build systems and stuff. If you're constantly building these images over and over again, and you're constantly pointing to Docker Hub, you're always reaching out to Docker Hub to pull these images down. You might want to consider for your application pulling in everything you need and storing it in a local registry. I wrote an article on DZone. I put a link here to it, and I'm actually going to provide it in the chat. I know if you go to that link at the beginning to get your t-shirt and your book, I'll have slides there too. So all of this information will be available to you as well, and I'll get them sent to James if he wants to post them in the group as well. So don't feel like you've got to hurry up and copy all this down or take screenshots. Should have said that at the beginning. But anyway, this article talks a lot about registries and what you might want to consider when choosing an image registry and managing all of your images. And also there is, I'm going to use the JFrog SaaS free version just to take a look around at some of the images. I'm going to push some images up there, and we're going to look at some of the data on them. If you want to do that yourself and do some experiments with images that you use, especially to look at vulnerabilities and things like that, you can definitely use this link to get a free version to play with. All right. That is all that I have as far as the presentation is concerned. You may follow me on Twitter or on LinkedIn. If you have questions about anything that we've talked about, feel free to DM me or send me a message. Make sure to go to the raffle page and get your t-shirt and book. And the last thing I want to leave you with is a little bit more about Docker official images, and then let's just take a look at a distroless image and specifically to see what it looks like in comparison to others. So I said, Docker has a bunch of official images. These are images that they're designated as official. It's very open. It's very transparent what goes on with these official images. Docker has a dedicated team that curates these, make sure that they're updated, make sure that we're aware if anything happens that we need to get an update for images. All of these actually live here in GitHub. There is in the Docker library, there is an official images section here, and if you click here and you click into the library, this is a list of all the official images that are currently available. Now, I've often wondered, I don't have the Docker file for the official image, so I don't know what all is going in there. I could use the Docker history command, maybe parse through that a little bit and figure out what's actually in them. But what I would really love to see is the Docker file. So let's just take one of these and look and see what's in there. Let's grab Alpine, for example. When you click into one of these, you'll be taken to a corresponding GitHub repo. Take that link and go check it out. Often there are different branches for the different versions. You'll have to do some exploring around to find what we're looking for, but let's just pick one of these at random, 3.10, and then you can pick a distribution. And within here, you will find a Docker file. So we pull that up and look at it. Look, this is as close to the beginning that you can get. Scratch is just absolutely nothing. That's the very start of building this file, and we can tell for this particular distro, this file is what's being used to create this base image for Alpine. All right. I should pay attention to all of the chatting going on here. If I don't get to one of these, please feel free to just unmute yourself and ask. Thoughts on tooling? I've used Dive before. I actually haven't used the other two, but Dive is pretty nice. It shows you pretty clearly what's in images.
I've used TotalLint. I like TotalLint just because I like linting tools.
Yeah.
I talk about it in my secure developer talk And that's one of the things. It just allows you to see things that you should and shouldn't be doing. You can use it as a pre-commit hook as well. It's actually really nice.
Oh, that's cool. Yeah, I love that. As far left as we can move that stuff, the better. Awesome. Okay, just for fun, I pulled down a few images. I pulled down the 11 JDK Slim image from OpenJDK, the full-on 11, and then I also pulled down the distroless image for Java 11 from Google. The reason you see multiple tags here is I've re-tagged them so that I can push them to my local registry so I can take a better look at them. But right away, look at the sizes here. So the Slim, we've got 429, full on, we've got 659 megabytes, and then the distroless is 206 megabytes. So pretty big difference in size for these in particular, especially given the full on Java 11 version versus the distroless. Notice this created section here, the distroless ones say created 51 years ago. That is just a result of the spec requiring you to put a date there. And the distroless images, they're meant to be genuinely repeatable builds. So they just stick a date in there that doesn't change. So the date doesn't really represent reality. It's kind of a hack to get a repeatable build. So I thought that was interesting. I wonder if that will change at some point, because that's a little off-putting 51 years ago. All right, I pushed all of these images into my local registry, and there's a view here. This is kind of nice because all of these, everything I push up here is just automatically scanned for vulnerabilities. And I just want to take a look at them because I'm told that a distroless image, since it's smaller, it's going to be better for you as far, from a security standpoint, right? Well, let's see if that's actually true. So let's go to our packages view here. I've got a ton of packages in here, so I'm just going to search for Docker ones specifically. I only have a few of those in here. All right, so OpenJDK, I've got two versions in here. I've got the Slim and the 11. Let's take a look at full-on 11 and take a look at the X-ray data here. And it looks like I have 69 security issues. Each one of these I can scroll through, take a look at, decide if I care about them or not. But something to note, look, we've got Python problems in here. Well, do we need Python in our image for our application to run? These are all things that you're going to want to consider. Curl, do we need curl in our image? These are things that you should really be going through and understanding what your application is made of and what it actually needs to live in the wild. So remember that number. It's an easy number to remember. Go back to OpenJDK. Let's take a look at the Slim version. X-ray data. Okay, here, this looks pretty good. Only 38. Now I'm just going by the number of vulnerabilities. Who knows, the quality could be different. So I think there were a couple critical ones in the full-on 11. There's one critical one here. It looks like the same one. We can find out a little bit more information where it's coming from. All kinds of stuff we can find out. We have the CVE number, so we can do some research if we care and want to go that deep. All right, so that's 38. Let's go back to the distroless image and take a look at that one. Oh, there's 51. Why is that? This would be a good homework assignment for you to go through and figure out, what's the difference? How come there's so many more? And just because there are more of them, do we care? Are these CVEs that we necessarily care about? But just from doing this, I wonder and want to challenge that assertion that a distroless image is automatically safer. So anyway.
Can we give you a distroless image to push up to see what the scan looks like on it?
Sure. Yeah.
All right.
Yeah.
In the chat, I just posted one. I literally just built it seconds ago. I'm kind of curious. All it has is BusyBox in it.
Okay. Find my terminal. Where to go? Oh, is it doesn't have any credentials?
Nope, nothing to worry about. Literally, it's BusyBox right in there. Nothing major.
Okay. Awesome.
And it's 11 megs, so it should be very tiny.
Cool. Lee. Give it my registry. And I'm just going to call it AMD 64.
That works.
All right, I have this repository automatically scanned. It might take a little bit to show up as a package, but we'll keep checking here.
I hope it's small enough it's quick.
Yeah. Sure it went there. Yes. Search. Take a little bit to show up.
I have to say,
Make
this
sure
runs
it actually made it in there.
This runs a lot better than Artifactory that we have locally hosted at work.
Oh yeah.
Oh yeah.
Yeah, I like this one. It's if you're interested in like the SaaS managed version, you don't have to worry about upgrading it or anything. It's pretty nice.
We can't with healthcare. It's not part of our policies. Yeah.
It has to be on-prem.
Yep. We have to own it. We've got an exception where we can host it in the cloud, but it has to be our cloud. So.
Okay, let's see if I can get it back in the packages view. There we go. It's not scanned yet. Okay. Be scanned. There we go.
The entire build is also, if you scroll up in the chat a little bit, when it says BusyBox example, there's the actual code that's built with in GitLab.
Oh, okay. Cool.
Distroless, yay.
All right. Well, so far I have zero vulnerabilities, at least with this database. That looks a lot better, right?
Mm-hmm.
Beautiful.
So X-ray can scan.
Scott noticed that 51 years old is Unix epoch. Yes, that is where that's coming from. I just saw that. Cool. Are there vulnerability scan results published for officially published distroless images? You know, I'm not sure if Google has that up there or not. I think it's up to you to check them out.
I don't think so, because technically it changes every day. I mean, there's vulnerabilities coming out every day.
Yeah.
I know one of the things at Ranch here that we've really encouraged our customers to kind of take the mindset of using sidecars for debugging is hey, make your image as tiny as possible, then make a sidecar image that can be as fat as possible. I don't care what you put in there, and then just patch your deployments. So we've had a lot of success with that. I don't care if you have curl. I don't care if you have whatever in there.
Yeah.
Just make it a sidecar so you can just inject it as needed.
Nice. Yeah, that's cool. Very cool. One thing to mention, I know we've got the Docker logo in here and everything, but it does support OCI images. So even if you aren't using Docker to build your images, as long as they're...
Actually, specifically, I wanted you to check that image because that wasn't built with Docker at all.
Oh, cool. That's an OCI image. Awesome.
Yeah, it's OCI standard.
Perfect. Yep.
So I do have a question. So in the future, are you going to have any support for SBOMs, like a registry for it?
Yes, absolutely. Yep. That is something JFrog is really leaning towards security quite a bit. They just purchased a company called Vdoo. I don't know if you're familiar with them or not. They're mainly around what do you call it? Doesn't matter. Can't think of the word. But there was a bunch of security engineers that came along with that company, and they've been providing a lot more information and improvements and upgrades to X-Ray, which is the security product within the platform.
Right. And I'm assuming that JFrog's really doubling down on trying to do anything they can do to stay a recommended tool within Platform One.
Yep. Definitely.
Awesome.
Oh, yeah. Well, cool. This was a lot of fun. The only thing I miss, though, is like the informal discussion and stuff after, I miss after a meetup group, going and getting a drink somewhere and just chatting for a while. But, we got to do what we can do. I do appreciate going to a Philly meetup group when I'm sitting here in Denver. So there is that.
There is that. I can always stop the recording when I always just hang out. We do something like that on Friday afternoons where we just talk about the weekly trends.
Cool.
Things like that. Anyway, well, Melissa, thank you for your presentation. That was awesome. I really liked the banana usage. It was a refreshing content because the dir thing was new. That was newer to me. But I liked the whole, like, I knew the story, but the bananas were like, and then when you were like, boom, use distriless, and it was a banana split. Great content. I appreciate that.
Cool.
Anyone, do you have any other questions for Melissa? Did everybody put in their feedback and then put in for the winning? We can repost that link for the shirts and everything. Other than that, Ari, do you have any closing words for us?
You said the slides and the talk are going to be at...
They're going to be on that link. I'll post them to the Cube Philly YouTube, and they'll probably just rehost them, right, Ari, onto the JFrog link.
Got it.
Yeah, we'll just embed it. We'll just embed it on our show notes page after you post it. So yeah, that's pretty much what we do. It looks like everyone here tonight will get it. If you just put in your name, you're going to get a T-shirt. Even if it was 17, believe it or not, I would send you all T-shirts. We had a situation once, and only once, where literally hundreds and hundreds and hundreds of T-shirts actually were requested. It was an interesting one, it was. So I've now put a limit on it, but that I can always go over my limit if I want to. So. But this is the T-shirt. Actually, this is the one that's going to be running out this year. So we only have a few more left, and I'm excited to give them out to your group. So
nice.
Thank you,
Ari. Melissa, any closing words before we break?
I think just don't believe everything you hear.
Keep giving this talk, please.
Trust but verify. Those are always good.
Actually, speaking of trust, as I was looking for where they hosted distro-less images, I just saw that Google cosigns, so they sign all of their images as well. That's the first use I've seen of that. So I heard the SBOM comment, but they're using cosign to sign their images. So that's good. Security's going in the right direction.
Yep,
awesome.
Definitely.
Well, thanks everyone for joining, and make sure to fill out your surveys. So thank you. Bye, everyone.
Thanks.
Great
Bye.
to see everybody. Take care.
Thanks, everybody.